Okay guys, here we go. We're gonna use algebraic operations, substitution method specifically to solve a system algebraically. So the first thing that we need to do is we need to look at the system that we have. So the fact that I have y equals 3 tells me that that's what I'm going to use to substitute. So anytime that you have y equals, that's the variable you want to substitute for. If you have x equals, you're going to substitute for x. So this tells me right here that I'm going to be substituting -3 in for y. Okay, so my next step is going to be to actually substitute that -3 into y in the first equation. So I have -5x minus 3 times -3 equals 14. Okay, so moving on to the third step, I can use the distributive property if necessary. Well, you don't have to use the distributive property here, so we can kind of skip that step. I'm just going to put a little NA for not applicable. And then I can combine like terms if necessary. So I'm going to just go back and simplify some stuff here. So I have -5x, and then I have -3 times -3, which gives me a +9, equals 14. Okay, so we're done there for now. Let's move on to step 5, which says I can use inverse operations to isolate and solve for the remaining variable. Okay, so the only variable that's left is x. So we're going to solve for x using inverse operations. So I'm going to start by subtracting 9 from both sides to get rid of that 9. And that leaves me with -5x equals 5. And then my last step would be to divide both sides by -5, giving me x equals -1. Okay, and I'm just going to kind of highlight that x equals -1. Okay, step 6 tells us that we can take that x equals -1 and substitute it back in to find the remaining variable, y. Well, we already know that y is equal to 3, so we don't have to do this step. So I'm going to skip this step and just write y. So we know that y equals -3. So it doesn't make sense to do extra work. We don't want to do extra work. The last step is to write your solution as an ordered pair. So I'm going to take this -1 that I know x is, and I know that y is -3, and I'm going to write them as an ordered pair. Okay, so for substitution, basically you're taking what you know and substituting it back in to find the other variable. Okay. The next example, we're going to tackle the same way, but it's just a little bit more complicated. Okay, so I'm still looking at what I'm given. So I am given, trying to get my highlighter here, there we go. I'm given y equals 2x. So I know that I'm going to be substituting in for y. So I'm going to substitute 2x in for y. Okay, so that 2x is going to go in where y is. So I have 3x plus 3 times 2x equals -18. Okay. Again, I don't have to do the distributive property. There's no distributive property there, so I'm going to skip that step. I am, however, going to look at combining like terms. Okay, so I have 3x, and then I have 3 times 2x, which is actually 6x, equals -18. Now, since these are both like terms, I can combine those, and that would give me 9 x's all together equals -18. Step 5 says use inverse operations to isolate x. So here I am dividing both sides by 9 to get x all by itself, leaving me with x equals -2. Okay. We are going to have to do step 6 because we don't know what y equals. So we have to take this 2 and plug it back into one of our original equations. Pick the one that's the easiest. So I know I need to find out what y is. So I'm going to use this y equals 2x because that's not going to be very hard for me to substitute. So I know that x is -2. So I'm going to substitute -2 in for x. And then that leads me to y is equal to -4. So then I take my x that I know is -2 and my y that I know is -4, and I write it as an ordered pair, and I'm done. Okay. Tune into office hours if you have any questions. Good luck.